So we are going to create a special order, and I'll write sine, but it will work for cos as well. When you have sine or cos and you have all those transformations, you can use exactly what we used in transformations and work from left to right and do your vertical stretch first, then your horizontal stretch or compression, then your horizontal translation, then your vertical translation. And you could take 5 points from your sine graph, your parent sine graph, or 5 points from your parent cos graph and do all those transformations. Now, because you're doing 5 points and you're doing a number of transformations, it ends up taking quite a bit of time. So what we do is we've done some graphing already and we've noticed some patterns, and those patterns are going to let us create a shortcut for graphing. And that shortcut for graphing is not going to follow the same order of left to right that we did for our transformations, because that's what a shortcut does, right? You notice some patterns and then you can do things quicker. So actually the first thing we're going to start with is our D value, our center line or sinusoidal axis. You're going to look at that D value and we've noticed that the only thing that changes our center line is that D value. So that's the first thing we're going to graph with a dotted line. So you're going to graph your sinusoidal axis with the dotted line as a starting point. Once you have that center line, our A value stood for our amplitude. And we're going to use our amplitude to mark our max and min values. So you have your center line, and then with your amplitude, you'll know how far up it goes and how far down it goes. And we saw that in the last example where our center line was -3 and our amplitude was 1/2. We could find what our maximum and our minimum was quite quickly from that. And that's going to help you find your range, and it's going to help you graph it quickly. The next thing that we're going to do is, once you've marked your center line and you know where your maximum and your minimum are, you're going to figure out what your period is. We're going to use that to find our period. And we always have divided that into 4 equal sections. Now, even though you're not completely done yet, because you've only done the transformations with the D, the A, and the B value, you're going to temporarily graph this. And you're going to, if it's not your final graph, graph it in a dotted line. But you have your period. If you know that if it's a sine graph, it's going to start in the center line going up. If it's a cos graph, it's going to start at a maximum. So those are things that you're going to figure out. Then after you've graphed it, then you're going to deal with your last section, your last thing, which is your phase shift. And you're going to move things left and right. And it makes kind of a nice acronym for remembering, DAB C. So I don't know, and it kind of is one word, and you have to take a break and say C after, so you have to do the DAB first, and then you do your shift after that. So it works out pretty nice. So let's see what an example of this graph looks like. You have space at the bottom of the page. Let's do one example. So here we have a sinusoidal graph with all the transformations. Draw your axes, y-axis. The first thing you're going to look at is your d value. That's our center line. We have a +1 at the end, so we know that our sinusoidal axis is at y equals 1. Our amplitude is 3. So the second thing in DAB C, after you've done D, which is your center line, is you're going to use your amplitude to figure out your maximum and your minimum values. So since our amplitude is 3, that means we're going to go up 3 to 4 above our sinusoidal axis, and we're going to go down 3 to -2. So we now know what our maximum and our minimum values are. So our center line and our amplitude helped us figure out what our maximum and minimum values are. The B, DAB, the B is our period. We figure out our period by our B value. Our period is always 2 pi divided by our B value because it's a horizontal compression. So our period now is pi. And if we divide that into 4 equal sections, half of pi is pi over 2, then pi over 4, then 3 pi over 4. And we're going to graph it temporarily. We haven't done our phase shift yet, but we're going to say, how does this graph look like before we shift it? And we're going to graph it with a dotted line just to get an idea of what it looks like. Well, it's a sine graph. Where does a sine graph start? Center line going up. So you go center line to our maximum, back to center line, down to a minimum, back to our center line. And we're just going to graph that because this is not our final graph, just with a dotted line to see what it's looking like. And then finally, you can do the C value. The C value is a shift. This time we're going pi over 4 to the right. So take each of those temporary points that you have on the green graph and move them pi over 4 to the right. And then you can graph your final graph. Just one other note. If you have a positive sine graph, right, it always starts on the center line going up. What happens if you have a negative sine graph? Well, that would be a flip over the x-axis. So it's going to start where? It's going to still start at the center line, going down. So if you had a -3 out in front, your amplitude would still be 3. But instead of starting at our center line going up, we'd start at our center line going down. If you have a positive cos graph, where do you start? Start at a maximum. If you have a negative cos graph, again, that's going to be a flip over the x-axis. It's not going to change your amplitude, but it is just going to change where you start. You're going to start at a minimum. Perfect. So now we have everything that we need to graph it all at once. Okay? And I think that using the DAB C is quicker than working from left to right, just because all of these points are dealing with pi, and you're doing compressions and stretches with pi, and then you're adding numbers, so that can be a little bit tricky if you're trying to do all that mental math.